Alright, we're going to get started here on the spacer rings. I think what we'll do first is we'll just use the corners here, find the center of these pieces of aluminum, drill a 1/2 inch hole in the center, be able to index this onto the turntable, and we'll probably have to lay out the bolt holes first to match the faceplate on the motor, those 4 bolt holes. So we'll do that, create those 4 holes, and then cut our large hole in the center using that process that we described earlier, drilling a hole through it, lowering a mill cutting bit down into that hole, and then turning the turntable to create that large hole. Once we get that completed, then we can pull this outside ring out or off from the turntable, round the edges with the bandsaw slightly, and then chuck it in the lathe using the jaws on the inside of that large hole, and then just true up the outside to kind of clean it up and make it look nice. So that's the plan of attack. Hopefully that all works. Let's get started. Alright, that should be our center. Let me get a center punch and I'll punch that, mark the other one, then back over to the mill. We'll use the same process to drill these holes as we did the holes in the adapter plate. We'll start with the little tiny starter bit, move up to medium-sized starter bit, and then a 1/4 inch drill bit, and finish up the hole with a 1/2 inch drill bit and then a chamfer. Let's get going. Alright, we'll drill the other plate exactly the same way. So we're set back up on the bench here with the turntable, got our holes drilled, actually matched up. I set both pieces on top of each other and spun them around, and hey, we're really close on the center of these things. Got, I don't know if you call it lucky, skill, probably more luck involved than skill, but if you turn them all 4 different directions, the edges line up real nice, so that's an indication that we nailed the center fairly close. Now, we did screw up a little bit here. Probably should have marked out these holes before we drilled the center out. While we had material in the center to help us lay it out, but we can recover from that by using this drilled piloted shaft in the center of our turntable. We can use that little divot there to help us lay out where these holes need to go. Now the dimensions that we're going to use are available on the HP EVS website, and I've already printed them. They're right here. Jetson. Oh, get your tail out of the way, Jetson. So from the center here, it's 800. From center hole to center hole is 8.4. Took me a little deciphering here on this drawing to figure that out, but I believe that's right, 8.4. So if we set our dividers up to half of that, so 4.2, 4 plus 200 thousandths should give us our dimension that we need to mark on our plate here by swinging our dividers around in this arc. What I'll do is I'll put a little Sharpie on here and inscribe these. Alright, I've looked at measuring this thing a couple of different ways, and I think we've got it laid out right. I marked this with the 4-inch circle there, which is the register here for the 4 inches, which matches up with the 4-inch register on the face of the motor. So that's pretty easy to mark out, pretty easy to double check. My dividers will go that wide, and I can lay it out fairly easy using the center point here and using my dividers to create this 4-inch circle here. And I can double check that with the scale here. And then I can measure from this ring out to our center point of our holes here. And then, of course, lay across here and double check that dimension as well. And that all works fairly easy. It's pretty easy to do. But the trouble I was having was measuring from the center point, just to double check things, measuring from the center point of the output shaft out here to the bolt holes. And obviously it's hard to lay the scale up here. I have done it this way, done the math, and double checked it that way as well. But the easiest thing for me to do was to lay out that 4-inch ring on the plate, the register for here, and then measure from there out to the center point of the bolt. And I created a little bullet here, threaded bullet. I just turned it on the lathe and left a little tiny nipple right there on the end of the bolt so I could measure from this register here out to the center of the bolt. And that worked. Sorry for the wobbling of the video there. But everything looks like it's in good shape. It's all adding up. I've checked it a couple of different ways, and everything looks like it's ready to go. So now we'll go back over to the mill and set the turntable up, center it here, and then work our way out to this dimension, and then drill it. Be able to turn the turntable 90 degrees to drill this one, another 90 degrees to drill this one, and then another 90 degrees to drill this one. I'm thinking about putting both plates of aluminum up there, drilling them both at the same time. That way they'll be exactly the same. We'll see how that goes. Okay, here's the setup. We've got the index at 0. Got the starter bit in the punched hole, and the material is clamped to the turntable. So we should be able to just use that starter bit, start that hole, turn the handle to the next 90 degrees, start the next hole, then another 90 degrees, third hole, another 90 degrees, fourth hole, change bits, and keep working our way around. Let's give it a try. I don't know if you can see that, but the first 90 looked like it dropped right on the mark. The 180 was off just a little bit, as well as the 270. But I don't know if that's my scribing or it's got to be. I'm going to take dividers and see how it works out, if they look like they're evened up. And if they are, we'll continue on with this process. All right, well, using the dividers here, they seem to be right on. So we're going to keep on going. So they all 4 of them look like they line up right where they're supposed to be. So we'll keep going on with that process, and hey, hope for the best. All right, a little bit bigger bowl starter. We'll pre-drill with 1/4-inch bit. I'll find a hole size of 3/8 of an inch. All right, both plates are drilled. I'll try to give you a little look down the holes to see how well they line up. There's the center hole. It's lined up fairly well, and then hard for you to see down there, but might be a slight misalignment there in 1 or 2 of the holes, but all in all, I'm pretty happy with it. I think it's going to work well. You know, if worse come to worse, we could ream them up a little bit, but as long as this dimension is good, I think we're going to be good around the on the outside dimension, anyways. So next step is to index these plates to the transmission adapter plate there and drill those holes. All right, this is what I've done. I've leveled the transmission. That's kind of hard to do because there's really nothing in the back of the transmission that's flat to set the level on. So There is kind of a flat spot here on the bell housing, and we've reproduced that or duplicated that here on our transmission plate. There's a little bit of a lip here where I didn't get it quite true, but it's close enough. This is just for eye appeal. When the transmission sits in the car centered up and fairly level, we want the motor to sit in there. I believe we want it with the wiring distributor block on top. So cocked off to one side or another would probably look strange. So as close to level as we can get it, that's what I'm shooting for here. So I put the level up here and leveled the transmission. Now I'm going to level these plates and then clamp them and then mark the holes through the holes here. Here's the setup for the adapter plate on the mill here. I haven't moved the table in the X or the Y dimension, so all we really needed to do was drop the starter bit into the center punch hole that we've made, because this dimension has not changed. I don't really have a good way of holding the plate down to the turntable. Wish I did, wish I could clamp it down, but I don't see a good way of doing it. I'd really like for this hole in the center to be drilled and tapped so I could put maybe a cap screw in there with a washer on it to help hold it down. But sometimes it's nice, like we used it earlier, to have that little just divot in there to run the divider on it, or the dividers on it. But this is going to have to work for us. I think it will. I got a nice good divot in each spot where we need to drill, so that should keep us or start us off in the right direction. So let's go ahead and drill these and see what happens. Alright, here we are back on the bench, and we got lucky again. I don't know if it's luck. Yeah, it's luck. I don't have the right bolts that I want to put in here. I'll probably order them. Maybe local hardware store, they've got a pretty good selection of the cap screws. They're 3/8 16 is what the motor accepts. Let's see, we've got 2 1/8 inch here, so they need to be probably 3 inches long. I'll double check how deep those threads go into the motor and get 4 of those. Here's just kind of a scrap 3/8 bolt that I had in with my stock, and you can see it does pretty good. There's a little bit of alignment issue there, but all in all, I think we're in pretty good shape. This one's a little bit snug too with this. Well, it's kind of burred up, so might take a reamer. I've got a 3/8 reamer I could run in there if we need to clean them up a little bit, but I think we did really well. Now the next step will be to start cutting the holes out of the center of these plates, as well as this one. Back over to the mill to do that. We can use these holes now to attach it to the table, and I think that's going to be a fun process. Okay, we're back over at the mill. We're set up, getting ready to cut our big holes here, and this is a pretty good setup here. We've got 2 T-bolts holding the stock to the turntable. We're getting ready to plunge this drill bit right into the material. We're back away from our line, our 4-inch line, by a good bit. We'll step it up to a 5/8 drill bit, and then we'll be able to lower the mill head or the mill bit down into the material and turn our table and cut this out. We're going to cut it out a little bit shy of the line, and then we can move the table back and forth as we creep towards the line until we get the exact dimension we want. Well, folks, a little snafu there in our filming. It's actually the next day from that last video where we were drilling through this plate, and it takes me a little bit of time to transfer these files over to my daughter's laptop where I'm processing or editing the film. And I didn't want to, she's at school, and I didn't want to stop working, so I pressed on without you. I apologize for that. I did not continue on this plate, but I chucked up the other plate and milled it, and actually put the step in it that we needed to make it attach to the faceplate of the motor. I'll show it to you next, and then we'll come back to this one and continue with the processing of this plate. So here it is. It came out really nice. Basically chucked it up in the mill the same way we did the other one on the turntable. Plunge drilled it and then lowered the mill head into that hole, rotated it around, cut this inside hole first, and then raised up the mill head to 1/4 of an inch here, and then milled, continued to turn the table and mill this out till we got to a 5-inch circle to give us a little bit more room inside this area where our drive coupling is going to go. It fits on the motor real well. The holes line up nicely, so I think we're in good shape. Now back on the mill, we don't need to make this step in the next plate or in the adapter plate, the transmission adapter plate as well. We just need this 4-inch hole. We don't need to make. We just need to go right to this 5-inch hole and make those in both those other pieces. All right, back over here on the mill. We learned quite a bit from doing the first plate. I plunged this hole pretty far away from our line, expecting to lower the mill head in and turn the table and just work our way out to this line, and that did work. It just took a lot of time to mill away all that material. It was, like I said, a lengthy process, and I think we can speed it up quite a bit by getting a little bit closer to our line with our plunge cut with the drill, and then just nibbling away at the outer edge of it. I think it's going to save us some time. I've marked out the 5-inch ring now, and I think we'll move the table out and plunge right next to it, and then just have to nibble out just a tiny bit to make our 5-inch hole. Now, this is not a real critical dimension. We'll use the calipers and try to get it as close as possible, just for practice and just for good machining. But it's not a real critical dimension. It's just a clearance hole for our coupling, and it's not going to be a big deal if it's 10-20 thousandths off. But we'll do our best. We're going to need to do the same process with the adapter plate, the transmission bell housing adapter plate as well. We can bolt it up the same way, plunge drill it, mill it, put the same 5-inch hole in it as well. We'll do that next. I haven't moved this table at all from milling the last one, so the distance between here and here is the final dimension of the plate if we have the right size mill head in there. Right now, this bit is this is a 1/2-inch bit. I can lower a 1/2-inch mill bit in there and take out this center plug, and then theoretically it should be pretty darn close to the final outside dimension, or inside dimension, I guess, as the old one. But right now, let's get the chuck off from it. We'll use our collet here to hold our bit and get to milling. I decided to go up to a 5/8 inch hole to give our mill bit just a little bit more room to work before we start off. Still just shy of the line there. All right, we're all set up here. We've got a 4-flute 1/2-inch mill chucked up with a collet. I've got us touched off so the mill is just touching the face of the plate here. Take a look at our depth gauge on the front of the mill, and we'll back the table back up so we're lined up with the hole, and then we'll lower the bit down into the hole by about 1/8 of an inch. And let's see, I gotta get lined up. There we go, down in the hole. All right, now we can start milling. I'm going to turn the table with my cordless drill on slow mode, and we'll lubricate the bit with some cutting oil, and we'll just keep making passes. We'll go round and round, lowering it by about 1/8 of an inch each time we go around. I got my shop vac ready because it produces a lot of chips, as you can probably expect, and we'll try to keep the mess to a minimum and also be able to see what we're doing. So let's get started here. It's going to be a noisy process, and I'll probably wind up speeding this up so it's not so boring, but you'll get the idea. All right, there's the first pass, and that was pretty aggressive. Couldn't get a good angle on the depth gauge, I guess, on the front of the mill, as the camera was kind of in the way, and it went a little deeper than I wanted it to. I just mic'd it. It's about 200 thousandths deep, a little bit too aggressive. My cordless drill had a hard time turning the handle on the turntable, so I wound up finishing it up by hand, and boy, it worked up a sweat. Mill didn't slow down any, so it handled it just fine, but pretty hard to turn that table. So normally, or at least with the last one, what I did, instead of lowering the quill, I would crank the table up, and I think I was doing about 1/2 a crank, and that's what we'll do this time as well, and we'll see what kind of pass we get out of it then. All right, well, that pass was a little bit better. It was about 100 thousandths is what we took off, so we're almost 300 thousandths into the plate. You got about well, a little less than 1/2 an inch to go. It worked better. It was easier to turn. My drill was still struggling a little bit. I wound up finishing it up by hand again. I did back off on the last quarter of it or so. I backed off on the brake. It kind of keeps actually they're meant for locking the turntable, and a lot of times when you're, at least in my experience, which is not a lot, when you're cutting like this, when the bit's cutting on both sides, it tends to rock the table back and forth in the backlash of the gears of the turntable. So by tightening this brake just a little bit, that seems to minimize that rocking back and forth, that jerking back and forth, the backlash of it. So I backed off on it a little bit. That made it a little bit easier to turn. I finished it up by hand, and I think we're going to go with the same process this time. 1/2 crank on the knee, which should run it up about 100 thousandths of an inch. I'll ease off on the brake, try to use the drill motor again, and try to get around for a nice clean path. You notice it's kind of a rough cut in here, but we'll smooth that up. Of course, this really doesn't mean anything to us. This is a plug that'll come out. We'll clean up the inside once we get the plug out, and we'll change bits and then be able to just kind of nibble away. We don't have much material to take off here, but we'll just kind of clean up the inside of this hole with a different bit, and it'll actually cut a little bit cleaner when it's not working both sides of the material. All right, well, we got through it. I think the bit had been working down from the very beginning. That last couple of passes after I got it tightened up, I'm not sure. I think some of it was the collet, some of it might have been the quill lock, but either way, it was certainly scooching its way down. And once I got everything all tightened up, it turned a lot easier. It was a lot cleaner pass, and the turntable turned a lot easier. So we're there. We got through it. This plug can come out now, and we'll get cleaned up. We'll change bits, and then just try to go a couple rounds in here to clean this inside edge up and make it out exactly what we want for our dimension here. All right, this is a 3/4 inch 4-flute mill bit chucked up, and like I said before, I haven't changed the table at all from the last plate that we milled. So theoretically, if we plunge this bit into the hole and made a round with it, it should come out to pretty close to the exact same dimension as the other one. Well, that seems like it's a good idea, but it's not. I think where it starts here, it's going to create a little bit of a different pattern. So plunging it down in is probably not the best way to go. I'm going to back the table up and lower the bit, and then we'll ease into the circle and hopefully make a nice finish on the inside. I've already mic'd it. It's at 4.98, and the other plate is at 502. So we've only got about 4/1000ths of an inch there that we need to, clean up the inside. If it doesn't clean up within those 4/1000ths of an inch, we may take another pass or two at it to clean it up. Like I said, it's not a critical dimension, so if it comes out a little bit bigger than the other one, so be it. But as long as I think the appearance of it getting cleaned up is going to be more important to me than actually the two dimensions being exactly the same. All right, so we're backing the table up. That should be good. Lower the bit in. And touching, we've got, touching's fine. We'll go ahead and tighten the quill. And what I'm going to do is get things cranked up here. We'll put a little lube in. And then ease the table. We'll crank the table and ease the bit into the stock, and then make a round with it. Well, you can probably see it helped a lot. It cleaned a lot of it up. It's not quite where I want it to be. Let me take some measurements and clean it up, at least suck the swarf out of there, and take some measurements, and then we'll see how much farther we can go. It looks like we're still about 19/1000ths under what the other one is, so plenty of room to clean up. I'm going to make another pass on it, and take off 4 or 5/1000ths on the inside, see what it looks like. We'll do some more measuring, and I think we're going to be in good shape. I think there's plenty of material there to keep going through this process until we get it nice and cleaned up. But maybe one more pass will do it. Well, there it is. You see it. It's showing 10/1000ths now, but it was at 9/1000ths there just a second ago. So still plenty of material to take off. I think we're taking about 4 or 5/1000ths off at a time, and it looks pretty clean. There's a couple little gaffs in it yet. I'm going to go ahead and make one more pass, and I think that'll do it. All right, back over here on the bench, and hey, would you look at that? That's no trickery. Well, hard to see, isn't it? But it shows us right on the mark. Well, it's all on how you hold the calipers. Well, it looks pretty good. Like I said, it's lined up real nice. There is, a few gaffs in it yet. That's where we started and stopped the mill. And for some reason, we get a little bit of a something there. I don't know if it's an impurity in the metal or actually where the original bit wobbled a little bit. Same right here. That definitely looks like a bit wobble. I think it had to do with that collet being loose. At one point, while we were cutting that ring out, the bit did slip in the collet, and I've never had that happen before, but certainly, here comes Jetson, certainly Jetson may have had something to do with it. But let's see, what do we need to do now? We need to figure out, silly cat. Well, I guess what we need to do now is we need to chuck the adapter plate up on the mill and go through the same process with it. We need to cut a 5-inch hole out of here so it'll match up with this plate. And this is how these things will be stacked. It'll be, of course, this plate attached to the transmission, then this will be the middle plate, and this one will actually be turned over like this and all bolted together, and this register here will help us index the motor into these plates. So that's how it's stacking up, and it's looking good. Let's get this adapter plate cut. We're set back up on the mill with the adapter plate. Plunge into the plate with the drill and upsize the hole, and then use the mill bits to cut the circle out. And I'm going to try to bring it right up to the same 5-inch dimension that I cut the last plate at. So I'll be back with you when I finish this. Alright, because I can't leave well enough alone, I'm going to change things a little bit. This is a 3/8 2-flute bit I'm going to use to cut the initial plug out of the center of it. I drilled a hole and then lowered the bit into the hole and then advanced the table or moved the table that direction to put the edge of the cutting bit up next to the hole here. My thought is this is a 3/8. It won't be hogging out quite as much material, so I should be able to get through it a little easier. I hope that'll work. We'll give her a try. Alright, I'm going to continue on with this process. I'll do it off camera so I won't bore you to death, but hopefully the collet will stay tight and we'll press on through. Alright, I'm going to bring you guys back in for the victory lap. You guys you got a good deal here. I got to do all the work. I've been cranking on this turntable. I guess, let's see, it's 750 thousandths. We're taking about 100 thousandths at a time, so I guess we've made about, well, this will probably be our 8th turn to complete it. And it's been protesting a little bit. I'm not sure if it's because of that 2-flute bit or it's a duller bit. I don't know, but it's had a lot of jerking back and forth pretty hard on the gears on the turntable. I've been trying to stabilize it a little bit with the brake in my hand, but we're about through it, and then we should be able to clean it up with the big 3/4 inch 4-flute bit. All right, success. Hey, we'll get the plug out of there, get it vacuumed up, get the swerve cleaned up, switch over to the 3/4 inch bit, make a couple of turns in there to bring us out to the line. Take more than a couple of turns, take probably 4 or 5, but we'll nudge our way out here to the line and get it all cleaned up. Take out this hole as well, and that should be it for the adapter plate. All right, you got it pretty well cleaned up. I just kept working it towards the edge of the line and also trying to take out the rest of that hole that just happened to be there, left from somebody else's deal with this plate. And unfortunately, I'm out 40 thousandths over what the other holes are, and I still haven't cleaned it up totally. I'll probably take one more pass on it. Like we said earlier, This dimension is really not a critical dimension. We're just opening up this plate so we can, it's clearance for our shaft, our coupling that's going to have to connect the two shafts. So it's nothing more than really personal satisfaction that we were trying to match these holes up. And right now, this bothers me more than the plates not matching up. So I'm going to go ahead and take another pass on it, try to clean that out of there, and then we should be done. We're back over here on the bench. We did pretty good. We wound up about 70 thousandths over on this hole compared to this one. Well, and this one as well, because these are both pretty close. But that's what it took to get the remnants of that hole out of it. And the finish on it is not quite as good as the other ones, and I'm not sure why. We use the same process, you use the same bit. I don't know whether that bit's just getting a little bit dull. I don't know, something changed a little bit because it's a little bit rougher finish. A little more chattering in there than it was on this one, as well as this one. But certainly good enough for our liking. And everything else lines up real well, so there is a little bit of a lip there between the two of them. But hey, nobody will know the difference, and you won't tell anybody, right? The next step that we need to do, and we've talked about it a little bit, is turning these round. And I'm having a little bit of a second thought on that. I'm going to have to kind of step back and take a look at it. But I've been thinking about the way that this motor and the transmission are connected together with these 4 bolts and the stresses that are put on those 4 bolts and the way it's going to sit in the car with the motor mount. Like all these projects, you got to kind of think 2 or 3 steps ahead when you're creating this stuff or engineering this stuff. And it looks like to me that there would be a lot of stress on these lower bolts. So I might try to incorporate the flat of the bottom of these spacer plates in the motor mount. I'm not sure on that yet. I'm going to have to sit down here and maybe do some more measuring and think about it a little bit more. And if that's the case, then we'll actually just round the top of these spacer plates off and leave the bottoms flat, which means I'd have to do it by hand, with the bandsaw, and then smooth them with the sander. I don't know. Give me a little bit of time to figure that out, and we'll get back to it one way or another. Well, there it is, all bolted together with just temporary hardware, and hey, it all fit together really nice. Real proud of it. I think after looking at it totally assembled, we are going to go ahead and turn these round. Like we talked about a little bit ago, my concern is looks like where this is going to sit in the car, the motor mount is going to sit here on the end, or have to be fabricated to fit here on the end of the motor. And then of course the other position is back here on the transmission mount. So you've got this whole assembly kind of bouncing down the road, working these 4 3/8 bolts. So that's putting a lot of stress on those four bolts. So if when we build the engine mount or the motor mount, if we cradle the motor here and then tie it back into these bolts, these are 7/16 bolts. There's 2 of them basically on a horizontal plane. That one's a little bit farther up than this one, but I think without much trouble we can tie those 2 bolts into our motor mount assembly and then create a little bit more structure there to help relieve the stress on these 4 3/8 bolts right here. Turning these round, I think, is going to be the next thing to do, and we'll get it back apart and get these over to the lathe. Actually, we'll have to mark them, trim the corners, and then get them over to the lathe and get them turned round. Hey, by the way, I'll put a still shot in this video somehow, but if you look down inside, this is the hole where the clutch throw-out bearing lever went through, and there's a pivot point down there for it. But let me see if I can, let's see, shine. Yeah, there it is. But the alignment on our output shaft and our input shaft is just about perfect. Looks really good, and about 1/8 of an inch gap between the two of them. So that all looks good. Let's get it apart and get those parts over to the lathe, get them spun round, and then we'll be done. Well, at least with this part. Alright, I went over there and chucked them up on the lathe and just held a Sharpie up to them and spun them around, marked kind of a wide circle on them. Take them over to the bandsaw now and whittle those corners off. It's pretty difficult to turn a square object into a round object on the lathe, so the closer we can get it to being true with the bandsaw, the better off we'll be, the less heartache we'll have over on the lathe. Alright, it took me about, I guess on the third one I figured out that, hey, 9 inches is about the minimum turn radius of my bandsaw. So got pretty decent at trimming it out. I think now we can get it over on the lathe, get it chucked up on the lathe, and clean it up, make it look pretty. This is kind of a weird setup. I've never had to set the lathe up like this before. Probably the biggest piece of metal that I've turned on it. I got it chucked up from the inside with the jaws, and it's pushed up against the back of the jaws here. So it's pretty secure in there. This is what's strange. The crosscut, or the miter, is set on 90 degrees. Normally it's set on 30 degrees, but now I've got it set on 90, and that allows the bit to get over here on this side of the material. Now the apron would bump into the material down here. Normally it would pass underneath it, but since it's so large of a diameter, it won't let the apron pass underneath it. So I've set up the stop over here, the way stop, to keep me from bumping the apron into it. And I've had, like I said, turn the miter to 90 degrees to swing the tool post around here far enough to get to the material. I think this is going to work just fine. It's aluminum, so it shouldn't cut that hard, and hopefully we won't get any chatter out of it. I've got a high-speed steel bit chucked up in here, and that should peel off the rough stuff fairly quick. When we get down, if it's not leaving a good finish, we'll switch bits or sharpen this one, whatever we need to do to kind of clean things up and make it look better. But let me get you set in the stand and we'll get turning. Well, I promised donuts, and donuts you got. It turned out pretty good. Didn't take long to true it up on the lathe and make it look nice. I ran a little bit of Scotch-Brite over it, shined it up a little bit. I'm pretty happy with it. I think it's going to work well, and looks decent as well. Got one more to cut there, and it's getting late out here in the shop. I'm going to call it a night, and then I'm back to work for a while, so be a little bit before I get back to that second one. I'm going to try to wrap this video up. It's another one that's gone fairly long, so I'm going to try to edit it and get it out there to y'all as quick as possible. Next task will be the coupling to connect the motor, output shaft motor, to the input shaft on the transmission. Going to require some more lathe work. Got it pretty well worked out in my head, a little bit of a drawing there, and I actually have been cheating a little bit and working on one of the pieces, prototype anyways, for one of the pieces that we'll need to turn on the lathe. I haven't cut tapers before, but have now with this practice piece or this prototype that I've been working on. So that's coming up next, episode 3, coupling. That's about it. Appreciate you folks watching and supporting me in this project. It takes a lot of work to put these videos together. I think working in the shop here, it takes about twice as long to get anything done when you're filming this stuff and editing, and you throw in the editing and all that it takes to get that going. You certainly get appreciation for the people that do a good job with it, that people take time out of their lives and out of their work schedules to educate all of us. So once again, folks, thanks for watching. Look for episode 3. Thanks for the support, and hey, good luck on your projects.